Hello, I'm Roy Ruddle, and this video shows you the fourth step of the six-step data quality method. I've been working in data quality for more than 10 years, and we developed the method with input from data scientists and analysts working in more than 15 industry domains. The method is freely available, and you can download it from this GitHub link. We have designed the six-step method to let you investigate the quality of your data efficiently, rigorously, and reproducibly. The benefits include being able to do more in less time because the method tells you what to do, reducing cost because we have grouped data quality checks into a carefully thought out order, and letting you get better results because by following our method you will understand limitations of your data, correct misheld assumptions, and be able to clean your data as you progress through the 6 steps. We have created 7 videos, an overview as well as a different video for each step. This video shows you how to do step 4 in a worked example. We are using the same car parking fines dataset as step 1. The whole dataset spans 9 years, but in the example, as in step 1, we're using just one of the quarters. So that's fines issued in January to March 2019. There are 8 variables, an identifier for each parking fine, the date it was issued together with the location, the contravention and the fine, and then 3 variables that are to do with payments of the fine, the last pay date, total paid and balance. In step 1, we removed a superfluous empty column and we noticed that some PCNs were issued 10 years ago. In step 4, what we're going to do is to perform checks on each individual variable. And there are 4 tasks that I'm going to use: unique values, frequency measures, and through that illustrate 6 different types of visualization, value lengths, and through that find some unusual category names. But there are also quite a lot more tasks that you should also consider performing. As I've already said, the method is freely available. You can use any software to perform the 6-step data quality method. However, in these examples, we are using Python, the Viz Data Quality package, and Jupyter Notebooks. Now let's do the actual analysis for step 4. We start by loading Viz Data Quality and the other libraries that we need. Then I'm going to read in the data file. I know from step 1 that it's in ASCII encoding. I'm only treating empty cells as missing values, but I already know there are no missing values. And after reading it in, I'm going to drop the extra blank column that we found during step 1. So that gets us back to where we were. Uniqueness is a general check that's useful for any variable. I'm going to start by calculating some statistics about each of the variables in the dataset using a convenience function that Viz Data Quality provides, and then plotting those unique values using a bar chart. Now you might think that this is just any old bar chart showing the unique values, but actually it's been carefully designed to be extra informative. So first of all, I've plotted the bar chart horizontally so I can have the labels here on the y-axis. That's something that makes it more readable when the labels are fairly long, compared with having them diagonally or vertically on the x-axis. Secondly, I've annotated the bars with the number of unique values. So we can see that there are quite a lot of unique values for the 2 dates, issued and last pay date. For the numerical variables, there is only a small number of unique values. In particular, we can see that there are only 2 different values of fine, which is what we expect from the data documentation. And that also tells us that we wouldn't want to visualize fines with, say, a histogram, but it would be fine to use to look at the number of times each fine occurs with a bar chart. We can see that For the two categorical variables, there are a fairly small number of different categories here. So that tells us that it would be possible to list these to the screen, or again show them using a bar chart or other types of chart. What I've also done is made the size of the x-axis here the same as the number of rows in the dataset, and that allows us to see at a glance the proportion of values in each variable that are unique. And so we can see that actually there are only about half as many PCNs as there are rows in the dataset. So let's look at the distribution, the frequency distribution of the PCNs. What I'm doing here is, first of all, I'm calculating the number of times each PCN occurs, and then I'm doing some extra processing to calculate the number of PCNs that occur once, twice, and so forth, and then plotting the output in a stacked bar chart. And we can see that a bit over 1,000 of the PCNs occur once in a data file, about 1,500 PCNs occur twice in the data file, and a smaller number occur 3, 4, or 5 times. Now this is a really important check to have made. It's a really important observation to have found. I use this dataset quite a lot in training courses that I give. And one of the most common assumptions that people make is that each row in the dataset will contain a unique PCN, and we can see that's clearly wrong. The dataset is correct. It's the analyst's assumptions that are wrong, and it's important for the analyst to correct their assumptions before they do the analysis. Otherwise, they're going to end up with the wrong results. So now we understand the frequency distribution of the PCNs. Let's go on to look at the other variables, starting with the fines. Now, if we just calculated the sum of all the values in the fine column, we'd end up with a number of £362,000. But we know that most of the PCNs occur more than once. So if we only count each PCN once when calculating the sum of the fines, we get a much lower number, the correct number, which is £200,000. That shows how important it is to investigate the PCNs and make sure our assumptions are correct, or in this case, correct our assumptions. Note also in what I'm doing here that I haven't just assumed that the multiple rows for each PCN would have the same fine value. I've actually checked that assumption. So the 4 columns for each PCN, which are set when the PCN is issued, the fine, issued date, contravention, and location, I've used that to check against the duplicates and validated with these two numbers here, 3,941 PCNs and 3,941 unique pairs. They are in fact duplicated rows for those values. If I want to visualize the number of fines of each value, then I can do that in a bar chart, and I see that most of the fines are for £50 and a very small number are for £70. Going on to the total paid, the same kind of mistake could be made if I don't take account of the multiple occurrences of most of the PCNs. If I add up the total paid column in the data file, I get a value of £191,000. But if I take the maximum, the actual total paid so far for each of the fines, then I get a much lower value of £106,000. Let's look at how I could visualize a total paid. And I'm going to start by using a histogram. So here I'm plotting all of the total paid values, and you'll see that most of those values are in the 0 to 25 and roughly 25 to 50 bins. There are a fair number of values in the £75 and £100 bins, smaller set of values here. And actually, if you look really closely, you might just spot that there appear to be a few values here in this £150 bin. This highlights one of the dangers of using histograms and bar charts, because the smallest bars can sometimes be invisible because there aren't enough pixels in them to be actually shown in the bar chart. There's a simple way around that, though. If you use the Viz Data Quality Library to create that histogram, and under the bonnet it's still using matplotlib, but what Viz Data Quality does is it uses something called perceptual discontinuity to ensure that each of the bars is visible, even if they're very short. So it distorts the bars a little bit. And now we can see that £150 bar really clearly, and we can also see a bin here round about the £230 mark, which was completely invisible in the original default histogram. Another way of looking at the distribution of numerical data is with a box plot. So this is a box plot, again with Viz Data Quality. Under the bonnet it's an absolutely standard matplotlib box plot of the same data. We can see that the interquartile range is sort of roughly 0 to £40 here, and then there are some outline values out here. That looks all well and good. But what if we use something called a violin plot? So this is showing, again, the exact same data, but violin plots are suitable for multimodal data, data that has many peaks in it. And so we can see there's a peak around about the £0 level. There's a peak around the £25, another one around £50, another one around £70, all the way up to the limit, the last outlier, at about £240. Whenever you're doing frequency distributions, it's important to understand whether or not your data is unimodal or whether it is multimodal. Violin plots show multimodal data, that is, where they have multiple peaks. Box plots assume that there is only one peak in your data. In this case, was fundamentally wrong. Right, let's go on to looking at the distribution of the date data. Dates and times are complex variable types in that they contain information at multiple levels of detail, but patterns at one level of detail may be hidden by noise in another one. You'll remember, if you've looked at the step 1 video, that we've already found that this data only contains date information. It doesn't contain time information, doesn't contain information about the time of day when fines were issued. So what I'm doing here, again with Viz Data Quality, and is in a single function call, asking it to produce and show me plots of the issued data at 3 different levels of detail. Starting from the right-hand side, we see that there's some variation in the day of the week when fines are issued. So it drops slightly on a Tuesday and much more on a Sunday. Maybe on a Sunday there are fewer people parking, or some car parks are actually free. The data file contains data both for fines that are issued and previous fines that were still being paid. So as expected, most of the issued values are from January to March, which is for the quarter of this particular data file, but it's plausible that there are a few from other months. If I look at the year, most of them are from 2019, the particular year of the data set, with a few that were older, but this is very, very strange that we also have some fines issued in 2009. There's something odd going on here, which we will look at in the next step. Also, it's worth highlighting that what Viz Data Quality does is it allows you to show the gaps in this data. So this is why the 2009 data appears as a dot, and then there is a complete blank here until the next year values, which are 2017. Last pay date is similar. In this case, I'm showing 4 levels of detail. This is the raw data in the top left. We can see there's some kind of pattern going on here. All of the data is from all the last paid years are 2019. That's what we expect. They're all from January to March, which is what we expect. And we're seeing some variation across the days of the week. So the last of the generic checks I'm doing in this step is something called value lengths. Value lengths is the number of characters in the values of a given variable. And to visualize them, I'm using something I call a dot and whisker plot. So if all of the values in a variable have exactly the same number of characters, so we see that's the case for PCN, fine, and the two dates, then it's shown as a dot. Whereas if the values have a range of lengths, a range of number of characters, then they're shown as whiskers. Having a range is not necessarily wrong, but when you get large ranges like this for location and for contravention, it's worth having a closer look. If we do that for those two variables, again using a convenience function in visDataQuality, which pulls out the shortest value, the median length value, and the longest value, what we see is that the longest values have a lot of trailing spaces. So we picked up a nice little issue there. I can also plot the number of times that each of the contraventions occurs. So we can see that most of them are for parking without displaying a valid ticket, whereas there are others that are extremely rare indeed. You'll also notice these sort of gaps here. This is another way of picking up the fact that you've got a load of trailing spaces after the text label of a given category. I can use the same kind of plot to show the location information. Where we can see that some car parks there are many fines, where other car parks there are hardly any fines at all. And then the very last thing that I do in this step is to clean up the data by stripping out any leading or trailing spaces from the location and contravention values so that I've got cleaner data when I move on to step 5. So in summary for this step, I've showed you 6 different ways of visualizing frequency measures. One of those is a bar chart, which is effective when you've got a small number of groups of data. Another is a histogram, but one of the problems with histograms is if there are not many samples in one of the bins, then it may not be visible, though you can overcome that using perceptual discontinuity through packages like visDataQuality. Another way of looking at frequency measures is a box plot, but that relies on your data being unimodal, that is, it having one peak in the distribution, whereas a violin plot will show you all of the peaks within a distribution. And so starting by checking your data with a violin plot is always sensible. Line charts are very effective for showing data at different levels of detail, such as dates and times. And finally, we showed a lollipop plot for showing value counts in different categories. A second takeaway from step 4 is always check your assumptions. With this data set, and I've used it quite a lot in different courses, most people assume that each PCN only occurs once in the data, but that is false. If the analyst doesn't know that, then they will end up making errors in their calculations. For example, the value of the fines that were issued and the total amount that has been paid, as I showed you. The third take-home is it's important to check dates, and if they're present in the data, times as well at multiple levels of detail. And visDataQuality lets you do that very easily in a single function call. Value lengths, the number of characters in a value. Value lengths are a good way of finding some types of issue with categorical variables. And through that, we found that we needed to strip the leading and trailing spaces from the contravention and location values. Once again, if you'd like to download the method, you can do so freely from this GitHub link. If you've got any questions, then do feel free to contact me. Thank you very much.